You ever have those moments where you're staring at a project, maybe it's a spice rack or a custom gate, and you think, I love this, but I wish it had a mind of its own. Like, I don't just want the gate to swing. I want it to know I'm coming and open itself up like it's happy to see me.
Tiger, if your gate starts acting happy to see you, I'm calling a priest, not an engineer. But I get what you mean. You want to bridge that gap between static object and smart machine.
Exactly. And for the longest time, that felt like black magic reserved for people with MIT degrees and lab coats. But then I stumbled into the world of microcontrollers, specifically the Arduino. And it's like someone handed me a digital chisel that works on logic instead of wood fiber.
It's the gateway drug of the maker world. But let's be real. For someone who spends their day with a table saw, looking at a circuit board can feel like trying to read a map of a city you've never visited. It's intimidating.
Tell me about it. My first attempt was, well, let's just say I didn't realize that electricity is a lot like water, and if you don't give it the right size pipe, it'll just burst the seams. I tried to power a chunky hobby motor directly off an Arduino pin. I thought, hey, the pin has power, the motor needs power, let's get married.
I'm guessing there wasn't a honeymoon.
Not unless you count the magic smoke leaving the chip. That smell, the ozone and burnt plastic, is the scent of a $20 lesson. That little microcontroller was trying its heart out to move that motor, but it's a brain, not a bicep. It can't muscle a load like that.
And that's the perfect place to start. For the folks listening who see these things as just blue rectangles with pins, how do you actually explain what an Arduino is to a craftsman?
Think of it as the ultimate middleman. It sits there, listening to the world through its pins. Maybe a light sensor tells it the sun is going down, or a moisture sensor says your prize-winning tomatoes are parched. And then it decides what to do based on the instructions you gave it. It's a tiny computer, but it doesn't care about TikTok or spreadsheets. It only cares about its loop.
The loop, that's the pulse of the thing, right?
Precisely. In the Arduino world, you have two main stages. You have the setup, which is like getting your tools out on the bench and making sure the shop light is on. You do it once. Then you have the loop, where the board just runs in a circle at roughly 16 million cycles per second. It checks the sensor, checks the time, flips a switch, and then jumps back to the start before you can even blink. It's like a shop apprentice who never gets tired and follows instructions to a fault.
To a fault being the keyword. If you tell it to turn on a heater and forget to tell it when to stop, it'll happily melt your workshop into a puddle while humming along at 16 megahertz.
Oh, I've been there. I built an automated dust collector switch once. The idea was simple. When the table saw starts spinning, the vacuum kicks in. But I wrote the code so nervously that every time the saw blade hit a knot and slowed down just a hair, the vacuum would oscillate on, off, sounding like a dying whale. My neighbor came over to ask if I was okay.
See, that's why I'm skeptical. You makers always swear it's beginner-friendly, but then you talk about oscillations and frying chips. For someone just starting, where do they actually plug the first wire?
You start with Blink. It's the hello world of electronics. You take an LED, that little glowing gumdrop, and you hook it to a digital pin and a ground pin.
Wait, we have to talk about the pins. We can't just skip the terminology. You've got digital, analog, PWM. It sounds like a bad 80s synth band.
Fair point. Look, the digital pins are the simplest. They're like a standard light switch. They are either on or off, high or low, 5 volts or 0 volts. Perfect for buttons or turning on a single LED. But the real world isn't always binary.
Right, because a sunset isn't just daytime, then suddenly night. It's a gradient.
Exactly. That's where the analog pins come in. They're like a dial. They can feel the in-between. Instead of just, is there light? They can tell you it's about 40% as bright as it was 10 minutes ago. On an Arduino Uno, they translate that world into a number between 0 and 10 turned 23.
And then there's that little squiggly line, the tilde, next to some of the digital pins, the PWM pins. Those are the ones that always trip people up.
Pulse width modulation. Sounds fancy, but it's just a trick. It's like flicking a light switch on and off so fast that your eye can't see the flicker. It just thinks the light is dim. It's how we dim LEDs or control the speed of a motor without needing a massive, expensive variable power supply. It's the board lying to your components to get them to behave.
I love that. Electronics is just the art of lying to hardware. So you've got your board, you've got your pins. What about the brain itself? You mentioned the Uno, but lately I'm seeing things like the ESP32 or the Nano ESP32 popping up in every project. Should a beginner care?
This is where the hobby has really exploded. The Uno's like a 1970s pickup truck. It's big, it's sturdy, you can see all the parts, and it's hard to truly kill. It's the best place to learn. But the ESP32, that's like a modern Tesla hidden in a matchbox.
Because it has Wi-Fi and Bluetooth built in?
Exactly. It allows your project to talk to the internet. I'm working on a moisture sensing system for my greenhouse right now using one of those. If the soil gets too dry, it doesn't just turn on a pump. It pings my phone and logs the data to a database. You can even run neural networks on them now. Imagine a bird feeder that can tell the difference between a cardinal and a squirrel and only drops seeds for the bird.
Wait, a squirrel-shaming bird feeder? Now you're talking my language. But isn't the coding for that a nightmare? I saw you typing in that Arduino IDE earlier, and it looked like you were trying to hack into the mainframe in a movie.
It's actually based on C++, but the Arduino team did something brilliant. They wrapped all the hard stuff in easy to understand commands. If you want to turn on a light, you don't write a page of machine code. You just type digital write. It's remarkably human.
Okay, let's talk shop reality. What's the biggest gotcha for a woodworker or metalworker trying to integrate this? Because we're used to physical forces. If I hit a nail with a hammer, it goes in. If I miss, I hit my thumb. In electronics, the injuries aren't always so obvious.
It's the common ground.
That sounds like a political slogan.
I wish. No, see, electricity has to return to its source. It's a circuit, a circle. I once built this elaborate motorized display stand. I had one power supply for the motor, and the Arduino was plugged into my laptop. I couldn't figure out why the motor was twitching like it was possessed by a caffeinated ghost.
And I'm guessing it wasn't ghosts.
No, I had forgotten to connect the ground wire from the motor's battery to the ground pin on the Arduino. Without that shared reference point, the control signal had no floor to stand on. It was just floating in the void. As soon as I clicked that one wire into place, everything smoothed out. It's the most common mistake for beginners, thinking that pieces of a system can talk to each other without being grounded together.
That's a great tip. What about the physical environment? A workshop is a hostile place for a tiny silicon chip. We've got sawdust, metal shavings, which are conductive, by the way, and vibrations.
Man, you're hitting on my biggest heartbreak. I had a beautiful little control box for my CNC router. One day, a single tiny sliver of aluminum, smaller than a grain of salt, drifted through the air and landed right across two pins on the board.
Let me guess, poof?
Just a tiny tick sound. That's all it took. Now, I'm a firm believer in the project box. If you're a maker, your first Arduino project should basically be building a home for your Arduino. 3D print it, laser cut it out of acrylic, or heck, even a Tupperware container with holes poked in it is better than leaving it naked on the bench.
It sounds like there's a lot of defensive engineering involved.
It's the same as putting a guard on your joiner. You're protecting the delicate bits from the messy bits. And speaking of messy, let's talk about power. You can't just shove any old battery into these things.
Right, the VIN pin. I saw that in the manual. 7 to 12 volts is the safe zone. But what happens if you're out in the field and you've only got a 18-volt drill battery?
Then you need a buck converter. It's a little $5 component that steps the voltage down safely. Think of it like a pressure regulator on an air compressor. You might have 120 psi in the tank, but you only want 90 at the tool. If you give an Arduino board more than 12 volts directly, the onboard voltage regulator has to turn that extra energy into heat. It'll get so hot, it'll literally desolder itself from the board.
I'm picturing an Arduino sweating and then just melting into a puddle. I can't take the pressure, Tiger.
It really does feel that way, but for all the frustration, there's nothing like that moment when the code finally takes. You hit that upload button, the little yellow lights on the board flicker like crazy as the data flows in, and then it just starts doing what you told it to do.
It's a different kind of craftsmanship. It's not about the grain of the wood, it's about the grain of the logic.
Well said. And look, you don't have to be a master coder. The Arduino community is the most open garage group of people I've ever met. If you want to build a temperature-controlled smoker, someone has already written 90% of that code and posted it for free. You just have to be willing to tinker with the last 10%.
So, if someone is listening to this in their shop right now, and they've been on the fence about buying a starter kit, what's the day one project you recommend? Not just blink, what's something useful?
Get an ultrasonic rangefinder. They're like $3. It's a little sensor that looks like two tiny eyeballs. Use it to build a parking assistant for your shop. When your truck gets within 2 feet of your workbench, it triggers a big red LED to tell you to stop.
Oh, I need that. My bumper has had enough conversations with my drill press.
We all do. It's a project that teaches you everything: how to read a sensor, how to use if-then logic, and how to control an output. Plus, it saves your paint job.
Before we wrap up, I have to ask, what's the one tool you think every Arduino beginner needs that isn't the board itself?
A multimeter, hands down. It's the only way to see what's happening in the wires. Without it, you're just guessing why your circuit isn't working. It's like trying to build a cabinet without a tape measure. You might get lucky, but you're probably going to end up with a lot of scrap.
Good call. All right, Tiger, I think I'm actually convinced. I might go pick up one of those Make Your Uno kits and see if I can't automate my coffee pot.
Just maybe keep a fire extinguisher nearby for that first run, okay?
Noted.
The big takeaway here is that microcontrollers aren't just for tech people. They're just another tool in the drawer. They let us add a layer of intention to our work that we couldn't get with just a hammer and nails. Don't be afraid of the code. It's just a recipe. And if you burn the first batch, the ingredients are cheap.
Love it. Thanks for the breakdown, Tiger. Next week, are we finally talking about that impossible dovetail joint you've been obsessing over?
Only if I can get the wood to stop mocking me.
See you then.